Hello, math humans. We're going to do 9.6 today. We're going to be talking about permutations and combinations. Our objectives are that we're going to talk about the basic counting theory, permutations, and combinations. So the basic counting theory talks about events, and we'll call event E, that can occur in M ways, right? And I think the best way to talk about that is to do an example. So for example number 1, we're going to talk about wardrobe options. Fun conversation. So let's say you own 3 pairs of pants and you own 5 shirts and then 3 pairs of shoes and then 2 hats and 4 scarves, because we do live in a cold climate. So we have hats and scarves. Alrighty? So the question is, how many different outfits can you make? And we have to assume that everything works together, so we're not going to be worried about things matching. We're just going to talk about how many different outfits could I potentially make. So the number of outfits is going to be generated by the basic counting theory. So I have 3 pants, 5 shirts, 3 shoes, 2 hats, and 4 scarves. And when I multiply all of the different possibilities together, which is the basic counting theory, I get 360 different outfits. And maybe different is changing only one element, but in theory, I would have 360 potentially different outfits. All right, so let's do another example. Example number 2 is Subway. And I love this example because almost everybody knows about Subway. So let's say when I go to Subway, I have 7 choices of breads. There are maybe 8 choices of meats. If you want to do cheese, there might be 4 opportunities to choose different flavors of cheese. You can choose if you want your bread toasted or not. So that's 2. Veggies, there are a lot, so maybe 10. Condiments, so mayonnaise, mustard, olive oil, blah, 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 blah. Maybe there's 5 choices. Chips, we love chips, so maybe there are 10 different varieties of chips to choose from. Soda, maybe there's 6 when you get your drink, and then you have a cookie, and maybe they have 4 different cookie options. So let's say we're going to do a meal deal, and it includes a bread, chips, a soda, and a cookie, and I want to know how many different meals. So how many different meals? It's a little bit entertaining. So if I multiply the basic counting theory, this is an event, this is an event, this is an event. So if I multiply all of those together, 7 times 8 times 4 times 2 times 10 times 5 times 10 times 6 times 4, you get that there are 53,760,000 choices for ways that you can choose your meals. So if you're walking into Subway with somebody that doesn't make decisions well, you might be there for a little while. So there are potentially almost 54 million different meals that you could choose. I think that's overwhelming. All right, so our next example, example number 3, talks about U.S. telephone numbers. Okay. So telephone numbers in the United States have 10 digits. Right? So typically it's 1, 2, 3, and then we have a dash, and then 1, 2, 3, 4, not including the area codes. Okay, so we would put an area code out front. Okay, but for right now we're just going to talk about the 10 digits. So it says if a local number can't begin with a 0 or a 1, how many numbers are possible within each area code. So notice that the rule that we've been given, we're not including the area code because some states have multiple area codes. We're also saying that this first digit can't be a 0 or a 1, but we haven't said anything about these digits repeating, which means they could potentially repeat. So we're going to use the basic counting theory, and we're going to talk about the options that we have for each number. So remember, typically we have the numbers 0 to 9 to choose for, and this is 10 different numbers if you include your endpoints. So for the first one, it says it can't be a 0 or a 1, so that means that I have an 8. And then for all of the other possibilities, I have 10 numbers that I can choose from. Well, if you do this, this is 8 times 10 to the 6th, which is 8 million different phone numbers, okay? So I would report my answer as the possibilities is equal to 8 million, phone numbers. And again, we're not even changing the area code. We're just considering the 10-digit number. So that's kind of entertaining. All right. The next thing that we want to talk about is a permutation versus a combination. These are considered statistics operations, but we need to discuss, we've talked about a combination already when we talked about Pascal's triangle and the binomial theorem. For a permutation, the order is important, and for a combination, the order is not important. So sometimes these can get a little bit confusing when you try to decide what the different possibilities are. I tend to think about my own personal thing is a reward and just fun. Okay, so this would be nerdy fun, talking about how many different ways can I arrange something. This would be maybe I potentially am going to receive a reward. So we'll talk about that in a sec. The notation for a permutation is P, N, choose R. So this is N things, and then chosen R ways. And again, this is an operation on your calculator. The official formula is N factorial over N minus R factorial, and we've talked about factorials already. I'm never going to ask you to manage this formula. We will do the math in our calculators, but this is how those numbers are generated. A combination, on the other hand, is the combination of N choose R is N factorial over N minus R factorial times R factorial. Okay, so again, you're not going to be responsible to know the formula, but it is interesting to know how these are chosen. So let's do a couple of examples. Okay, so example number 4 might say in a group of, and I'll move my paper up so you can see, in a group of 10 people, three $5 prizes will be given. How many ways can the prizes be distributed? So I guess my way of talking about a reward, so it's really not talking about giving out a first, second, or third place award. It's just asking how many different ways can I give out a $5 prize. So this would be a combination of 10 choose 3. There are 10 people and they have 3 prizes. So this would be 120 different ways of distributing the prize money. Another possibility is for a combination would be a locker combination. Okay, and actually I lied, that would be a permutation. So a locker combination would be a permutation. How many different ways could you do a combination? And the reason that this is a permutation is because the order is important. So if you think about, if I am trying to open a combination lock, if I do the numbers out of order, the lock doesn't work. And so the order is important. So that would be a permutation. Alrighty, example number 5. How many ways, except I spelled it wrong, how many ways can 6 people ride in a 6-seat car? So this is entertaining, and it's a version of the basic counting theory. So when all of these people try to get in the car, the first person has 6 seats to choose from. Well, now one of the seats is gone, so the second person has 5 seats to choose from. The next person has 4. The next person has 3 and 2 and 1. This is 6 factorial, or 720 different ways you can fight over seats in a car. Alrighty? This is also the same thing as a permutation of 6 choose 6. I think this is a little bit interesting because, in my opinion, the order is not important. I'm using the basic counting theory. All right. I will tell you, though, that mathematicians say that the basic counting theory is going to be relevant toward a permutation. So let's do another example, and it's our last example. Example number 6, you are forming a 12-member swim team from 10 girls and 15 guys. The team must consist of 5 girls and 7 boys. How many 12-member teams are possible? And so this is one of those situations where statistics gets a little bit weird. So we're assuming, and maybe not correctly so, and usually not correctly so, that athletic ability or coachability or anything else is a factor. We're dealing strictly with numbers. So we're going to assume away reality, and then we're going to try to make a team. We're also going to have to assume away that making the team is important. So in this case, we're physically talking about how many different arrangements can I make. Not talking about talent, not talking about athletic prowess, and not talking about coachability. So that's going to be the combination. So I'm going to have 10 girls, and I'm going to choose 5, times the combination. I have 15 guys, and I'm going to choose 7. Okay. This is the counting theory. I'm multiplying my options together, but my options actually are combinations because we're not assuming that they're winning a prize of any kind because they're on a team, even though I would think that's a prize. So the moral of the story is there are 1,621,620 different ways that you can choose a 12-member team. Again, this isn't reality, so we've assumed away reality, and we just wanted to do some number flipping. Okay, so I'm going to give you another example just because I can. This will be our last example, and this says a combination lock will open with the right choice of 3 numbers. and we're going to do 1 to 50 inclusive, meaning that I can use the number 1 and I can use the number 50. How many different lock combinations are possible? Now, this is not talking about how many can I use to open the lock. This is maybe I am a combination lock manufacturer, and I'm wondering how many I can make. So I'm going to choose 50 for the first one. I'm going to choose 50 for the second, and 50 for the third, which means this is 50 to the third. There are 125,000 different ways that I can make that combination lock. All right, my dears, that is it for today. I will see you soon.